Hello, my name is Jonathan Shelley, and today I'll be presenting our work on determining contributions to injury risk in native versus non-native signers. Studies show 81% of fluent signers report pain, and of those assessed, more non-native signers experience pain than native signers, where native refers to a signer who was born to at least one deaf or signing parent, and non-native refers to a signer who was born to non-deaf or non-signing parents. To explain this difference in pain prevalence, a study determined 5 biomechanical measures unique to signers, which include muscle tension, which is prolonged muscle activation, micro-rests, which are very short breaks in signing taken in between words, ballistic signing, which is abrupt or forceful production of hand signs, hand and wrist deviations, which are unnatural joint positions away from a neutral position, and work envelope, which is the area in which signs are produced in the upper limb workspace. However, no studies have quantitatively confirmed whether these biomechanical measures influence pain in signers. Therefore, we aim to determine the differences in native versus non-native signing and whether the 5 biomechanical measures are different between native and non-native signers. 25 signers were studied, including 10 native and 15 non-native signers. Each participant was asked to sign along to a 7.5-minute video with audio and closed captioning while motion capture and surface electromyography, or EMG data, were recorded from bilateral upper limbs. From here, the 5 biomechanical measures will be quantified in the following ways. From EMG data, muscle tension and micro-rest were quantified by measuring mean muscle activation and breaks in muscle activation, respectively, with surface EMG equipment. Hand and wrist deviations, ballistic signing, and work envelope were quantified using the motion capture system, which tracked 3-dimensional locations of markers placed as shown to the right. The differences between native and non-native groups will be determined for each of these measures, and we will examine these differences by using the quantified biomechanical measures as inputs to a factor analysis, which will be implemented using a custom MATLAB script. Factor analysis is a computational technique that identifies factors which are variables that explain variances in input data. We will select factors that are able to explain the variance of all of the 5 input variables. The goal of this being to determine the relative contributions of each of the 5 measures to the differences in signing between native and non-native signers. One way to represent the individual contributions of the biomechanical measures is a loading plot, as seen by the figure on the right. From this sample figure, we can interpret biomechanical measures 1, 2, and 3 as having a contribution to the variance captured in factor 1 by observing the relatively high slopes of their lines, while biomechanical measures 4 and 5 can be seen to have a significant contribution to the variance captured in factor 2 by observing the relatively small slopes of their lines. Numerically, this can be represented by calculating eigenvalues for each variable, where larger values will be interpreted as stronger association with the variances captured in each factor. And while this work is currently underway, we anticipate identifying strong associations with the 5 biomechanical measures. Outcomes of this work will give more insight into the mechanisms that may contribute to the differences in signing and injury risk, and identifying the relative influence of each will help us to prioritize which factors present the greatest risk so we can develop mitigation strategies and in the future prevention strategies. Thank you to the funds and people that supported this work, and thank you for your time. I look forward to the Q&A.